Hello again, this is John Michael O'Brien, and this is the second video in a series of videos about doing cosplay LED lighting. So if you remember last time around, or if you haven't, great review, this was the simplest possible circuit. We talked about solving out for the resistance using Ohm's law. We talked about Kirchhoff's voltage law, which says that all the stuff over here has to add up to what you have over here. Now, the problem is this is inefficient. In the last one we used 9 volts, a 3 volt LED, which meant we had to waste 6 volts of electricity through that resistor. This is not the most efficient way of using our energy, not by a long shot. The thing is that we can put multiple LEDs in series. So if we imagine a really simple case where we have again a 9 volt battery, and instead of putting in one 3 volt LED, we put in 2. Oops. And we put in our current limiting resistor, because otherwise our LEDs pop. There you go. What we find is that we can still solve this out. So we have 2 voltages. So what we end up with is that 9 volts is equal to VD, or the drop across the diode. We get that out of the data sheet. So it's equal to 3 volts plus 3 volts plus VR. We don't know VR yet, but we can get there. 9 volts, we can simply rearrange. We get 9 minus 3 minus 3, which is just simply 3 volts, is equal to VR. Okay, so now we know our voltage. We come up here, go Ohm's law. Ohm's law, we know we've got a 20 milliampere diode, so we go 3 volts divided by 20 milliamperes, or 0.02 amperes, is equal to 150 ohms. So, we now know from this configuration that if we put a 150 ohm resistor here, this little circuit will happily produce 2 LEDs worth of light for the same 20 milliamperes. It's worth noting that a battery essentially is rated in a number of milliampere hours. It's how many hours it can operate given the draw of that many milliamperes. If you draw less than that, so for example, 9 volt batteries, the standard rectangular cells are typically about 500 milliampere hour. So you take this 500 milliampere hour and you draw 20 milliamperes out of it, yeah, we'll call it 400 milliamperes to make the math easy. It essentially means that now that we're going to run for just about 20 hours. So the thing is that the fewer, if we were to put another pair in here, so let's say we did this, every time we do a parallel circuit, the currents add up. So each of these is 20 milliamperes, right? Well, that means that this guy here, the current coming out of the battery, is the sum of the two. So we end up with a total of 40 milliamperes. The exact logic for that is called Kirchhoff's current law. We're not going to cover. Just know that every one of your series strings here each series string, when connected in parallel, adds up its current. So if we draw 20 here, we draw 20 here, we draw 40 out of the battery, and now our battery, instead of lasting 20 hours, is lasting 10. So, obviously, we want to put as many of these LEDs as we can together. Because before, let's say we made 2 of these, so 20 milliamperes each, we would only have 2 LEDs lit up for our 40 milliamperes. Here we've got 4. Now, there are other ways we can go beyond this that will allow us to get a lot more out of it without having to spend more, basically without even having to have the resistor at all. But there's a whole bunch of exceptions and exclusions, and you have to be careful with it. We're going to cover that in the next video, so if you're curious, feel free to tune in. If not, this is probably the best implementation. So basically adding it up until your VDs, when they add up, is something slightly less than the battery voltage. Here I'm using 3 volts and 9 volts, so things don't quite work out the way they work in real life. If these were like 2.6 volts, which is typical for a blue LED, you'd end up with about 3 of them, and then a little resistor at the end to clean it up. So the trick is that this configuration is probably your most direct approach for getting efficient energy usage out of your system. Just be aware that you'll need a resistor for every one of your parallel strings. So with blue LEDs and a 9 volt battery, expect to have at least one resistor for every 3 LEDs you work with. Again, this is John Michael O'Brien, and if you're interested in seeing what happens, what we can do to make this even better, feel free to tune into the next video, and we'll go over how to get that resistor out of here and what we actually have to give up to do it.